Hey everybody, this is Larry. This is Weekly Contest 436. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this contest, today's problems, everything in between. So I'm just readjusting my desk. I have too much crap on it, honestly. But I got my notebook ready. That's the other thing, and my pencil, making sure that it has lead. And who is ever ready, right? I'm not ready, but it's fine. I took a good nap. I ran a couple of miles. We have 30 seconds to go. Let's go. Huh? Yeah, I've been making a lot of silly mistakes lately, but the problems have also gotten a little bit harder. So I don't know what the right Larry specific strategy is, frankly. But I don't know. I think at the end of the day, the goal is still just to have fun and see if we can learn along the way. And yeah, everything else will be fine. 3, 2, 1, go. What? This is a Yeezy? I mean, it probably is easy, but it's just so much reading. Mod 10, okay. Okay, fine. I think this is right. Okay, yeah, that part is right? So then now, maybe... Okay, and then now while length of S is final 2 digits, right? So it's greater than 2, then we just return S of O is equal to S of 1, right? So it's greater than 2. Then now new S is equal to for XY in pairwise S, NS dot append X plus Y mod 10, right? And then S is equal to NS. And then, yeah, that should be good. True false, I mean, probably okay. YOLO submit, okay, good. Probably could have taken an extra 20 seconds on that one, but I don't know. All right, let's go. 2D matrix, limits, integer k, maximum and most k elements in the graph such that the number of elements I does into ith row does not. Okay, so you can only take these number. Okay, it's still going to be just heaps, right? I mean, I don't think there's any difference other than yeah, heaps or sorting, whatever. Yeah, okay. Yeah, okay, whatever. And this is a typing problem, so gotta get it quick, I suppose. Just don't make a silly mistake. Right, and then we just have a heap. Right. Grid sub I of 0. Oh, this is an I. That's why I was like wondering where the O came from. Grid sub I and then I, right? We'll maximize or minimize. Maximize. So that means that we want the negative. Okay, fine. Right? Yeah, we're good. And then now for we want to take k of these, right? We want to say limits up. I mean, it's fine. We just have to keep track, right? Maybe just counts of. I mean, you could probably do this implicitly, but I want to do this explicitly. Okay, so then now, q.heap_pop of h will give us the value and then the row number, right? The value doesn't matter yet. I guess it does, right? So then now, if index or if counts of okay, while true, we have this thing want to pop if the count is less than limit subindex, then we are good. Then we just and then we add it by the -v. Otherwise, we have to put the next number in the heap. Yeah. So then now grid subindex dot pop left, and then we have to go if length of grid is if length of grid is greater than 0, then we push it back into the heap. And otherwise, that's it. Otherwise, we don't do anything. It just pop again and get another one because it is over the limit. Deck index out of bounds. On which one? On this one? Oh, it's grid of index. Whoops. Okay. Oh, I have to break here. 721, probably okay. Wait, double check. K could be R times C, which is 2500. That should be okay. All right, let's go. If it times out, that'll be a little bit sad, but I think that should be okay. Okay. We're doing okay. We have a 6-pointer and an 8-pointer. So let's see. After operations 2, okay. It's just that now it could be really big, so n squared is not good enough. For Q1, we did have an n squared solution, so yeah. Okay. One person gotten it. How about Q4? Also one person gotten it. Let's see. What does that look like? The contribution of the last thing, right? So it's just a sum of a lot of numbers. Right? So then now, it is just Pascal triangle, right? Yeah, it's just Pascal triangles. Not that bad. Pascal triangle. It is n factorial over k factorial over n minus k factorial, right? Okay. So then it's just that, and then it's just doing the math with modular inverse. That's awkward, but fine. Okay. And then factorial is equal to 1, and I guess we have to put it outside. I don't know why I did that, but yeah. Mod. It's mod 10, right? Yeah, I think mod 10 is fine. And then do. Can I do mod 10? Is that right? I mean, it should be right, but okay. Let me verify this. If this is true, then you have 4. Then it goes to the triangle. Okay, let's write it out. Where to 4? You have 1. You have 2, right? And then now you have 1, 2, 1, and then 1, 2, 1 as well. Alright, so then now we're just checking whether this number, yeah, so it's just, so it is thing, but how do I do it with respect to mod 10 though? Because that's not, you can't do a modular inverse on that. You've done it. I mean, the idea is right, but I don't know how to do it necessarily. Yeah, okay. I guess it's just last digit math, right? I forget there's a last digit, so you can't do this. This is fine for the factorial, just number of factors. So then you need the prime factorization of every number, which is, no you don't. You just need to count the number of 2's and 5's. Yes, okay. How do people get so fast? I mean, maybe they have libraries, I don't know. Okay. Okay, focus. And I think this is fine. But you still have to do the math, right? Okay, fine. How do I want to write it? Okay. Do I need it like that? I think so, maybe. I don't know. Okay, that's... Is that fine? Actually, because then you have the 2 and the 5's and the rest. But can you mod that? I don't know. People are getting it though, so is there a smarter way to do it? Let's see. Okay, so let's say if n is equal to actually, let me try something real quick. It doesn't make sense, right? Oh, wait, no, this isn't the last digit, right? This is the last digit. I'm thinking of the one problem. Okay, so if it's digit, then okay, let's... There's some math here. So, okay, so it becomes 10 for sure. Okay, so then what if n is equal to 10, right? Okay, so 5, and then now it becomes that, right? Is there a pattern here? So it's 1, 6, 15, and then 20. How do you determine this? Is there a better way to determine this? And is this even right, at least? How slow is... I think this might give me a string too long error, actually. Yeah. Is it fast, at least? I don't know. Oh, I shouldn't print it. Oh, well, it's too late. I mean, it's not fast, but... Oh, but you still have to loop it, right? So maybe if you do something like... just this... Like, that would be too slow already, so that's not that fast. So we have to sum that. I mean, even if you spell half of it. Yeah. So we can't do it that way. We have to be able to do it. Is that anyway? No, I want to So okay, so well, so n choose 1 going to n choose 2 is going to be what? You times it by k, and then you divide it also by n minus k. Right, because n over 1 is going to be n minus 1 factorial, 1 factorial, and then going to 2 is going to be n factorial over 2 factorial, n minus 2 factorial. And what is the change? The change is that you multiply 2 and you divide it by an n minus 1. How do you do that? Yeah, I'm just bad at math, maybe. I mean, you can't do an n squared to calculate this, so that's the hard part. This is a problem where I had to skip. People are already done. What is that? Only 4 people got now. I feel like I should have I mean, I know the idea behind this one, but I don't know how to do the mod 10 part. Let's see. Is there another way of doing it? Do we need to know the math? Okay, maybe it's the delta. Maybe I don't need to know the math. Okay, so it's 1, 2, 1 minus 1, 2, 1, right? For 3, so that means that it has to be subtracted as equal to 2, right? That means that here, they don't really cancel out, right? So it's actually 1, 1, 1 is equal to 1, 1, 1. Okay. We can check that, right? So that means that is the sum of these 3 numbers, which is 2, these 3 numbers, which is 1. Well, that's wrong. Well, they're different. So it's basically, okay, so then that means that you have 1, 1, negative 1, negative 1 is equal to 0. That means that this is 12, this 2, this is 2, and that's good. All right, let's try another one. 1, 3, 3, 1, 1, 3, 3, 1, right? That means that you have 1, 2, 0, -2, 1 for 5 numbers. So that means that it is, but I don't know how to generalize this, right? So that's not, okay, so that means that 7 doesn't matter. You have 1 and 2, so that's 8, that's 11. Negative of this, 16 plus 25. Wait, what did I say? 8, so 11. 16 plus, well, I mean, this is a 4, so I guess that's why it doesn't work. Okay, so that's 1, 3, 3, 1, right? So what's 1, 4, was it 1, 4, 6, 4, 1 or something? 1, 4, 6, 4, 1. We subtract, it's 1, 3, 2, -2, 3, -3, -1. But that's the thing, right? Is that you still need the binomials then, right? Like, I don't. Okay, let's see. I don't know how to get the last digit on this one. People do apparently. So let's see if I can see a pattern maybe. Because it's not just that, but okay. So that means that okay. So let's just say we print. Right, so here let's just say 6, right? Okay, I mean I shoved in a, okay, that looks like a 6. Well, 6 has 7 numbers, which is I guess right, but so 6 includes, but okay. So then now we want this to subtract by oh, that's why, because it's off by 1. So actually it's this minus I plus 1, maybe. So then on 6, no, this is, it should be I minus 1 maybe. It doesn't count the first one, I suppose. So okay, so okay, so current is equal to, it feels like it's not necessarily an easy one, but it shouldn't, I don't know, it feels like it's a knowledge one, and I don't know how I know that thing, and maybe I should have done the next one, I don't know. If I don't see a pattern here, then I'm gonna do, okay, so 6, let's just do some, okay. Okay, I mean that looks more right, except I have to do a 1 at the end, but that's fine. Alright, so that's okay, and confirming the things that I did manually. 3 is 1, 3, -1, -1, so that's for 2, for 4 numbers, right? So for 4 it should be 1, 2, -2. Am I off by 1? For 5 numbers. Oh, for 5 numbers this is right, yeah. No? I'm off by 1 somewhere. 1, 3, 3, 1. This is very awkward actually. It's always a 0 somehow. That doesn't seem right. So I think I'm off by a little bit. But I'm just want to see a pattern. This should be, so 4. You have 3 numbers. That means that you want 1, 2, 1, 1, 2, 1, right? 1, 2, 3. Choose 0. Is 3. Am I just off by 1 and I'm dumb? I mean, maybe. Why am I so bad at this? The 4 numbers, you want 1, 2, 1, right? Okay, let's not ignore this for now. That's wrong. That's why. But so 4 numbers, this makes sense. But we actually don't want that. We want for 4 numbers, we want n I'm just really bad at this, I think. Okay, so you have 1, 2, 1, and then now okay. This is more right. I mean, kind of the last digit because of this thing of the last number, but something like that. Okay, maybe it's a little bit wrong. I can't even get this right. What is wrong with me? What I want is just 1, 2, 1 minus 1, 2, 1, but off shift, right? All right, whatever. I can't even write dumb code correctly. I'm having a rough day. I think this has always been a rough day these days. All right, 1, 2, 1. Okay. Yeah, and this right. All right. So then now we want to subtract this from. Yeah, right. So then, right. Press enter, say, right. And then enter that append 0, and then whatever, enter 2. I'm just being really dumb. Alright. Alright, now we're able to see what we okay, now we're able to see what the thing. Okay, so that's 4. What does 5 look like? Yeah, okay. Is there a pattern? Let's see. All right. Maybe I should print n here. It doesn't matter that much. Okay, so 9. I don't know. Like, this doesn't. I mean, I know that's symmetric. That's a easy pattern to see, but I don't know that there's a easy thing, right? Like, basically, this has to sum to 0, which is fine, but how would you, Catalan triangles. Okay, but I mean, I don't know how to do this. I'm missing some. I mean, is it just like mod 2, mod 5 or something? I don't know, but. You can't just do division that way. I don't know how to do an modular inverse of these things. I don't know, maybe 153. Maybe I suck at programming these days. But we can't even do math.com that big, right? So we need something funky like this. Even though, I mean, I have the idea, I just don't know how to do it. Spent so much time on this problem. What a silly contest. I mean, is there another way? I mean, I don't know. I don't see a pattern for this one, huh? And this gets pretty big pretty quickly. I mean, no real pattern that I could tell. I mean, there are a lot of zeros and fives, but that doesn't even help me enough because you divide it by zeros and five by powers of 10. So how do 200 people get this one? Am I just that out of shape? I have this one just in case, but I mean, what else am I thinking that I'm not doing other than I mean, yeah, to generate this, I need this anyway. So this is, both of these are kind of not that useful. I was hoping that it kind of, a lot of things canceled out in a way that I can figure out, but clearly that's not really the case that I can tell. So that's not really useful. I gotta stop doing these contests. I don't know how to do anything. 34 people got in that one. Should I have spent that time? 200 people got this though. I don't know how I'm messing this up. I mean, yeah, I don't know how else to think about this. I was gonna test something funky, but Is there another way to think about this? What do we use big int? I don't know. Maybe I can. No, that's 6 more digits every time. So maybe you would have something like. Okay, so you start at 1. Times I divided by I, or the other way around, maybe? I don't know. No. Something like that. Does that work? Is that the same as we had before? Nope. Maybe I'm off by 1. Last one. I'm just being lazy, honestly. Yeah. That's right, but it's just that this is going to be too slow for n as you go to whatever, right? I know that's for a given n, so. Okay, so how long would this take? It looks like it's timing out, and memory limit exceeded. Just not a big issue, but also kind of is. I just don't know how to do this. Alright, Q4. Apparently I don't know how to do this, so let's just do a Q4. Apparently a lot of people know how to do it though. Am I being dumb? We did it in 8 minutes. Let me give it another dot real quick. Yeah, this is. Do we need to know that one? This one? Oh, this is a bad one. Or the last digits, almost all, which is almost as bad. How do I feel? Okay. Is this fast Fourier transform? I don't know how to do this. Alright, let's go cute way. I'm just gonna suck it up. Alright. You have a square. Choose k is equal to 4. What's k? Choose such that. Okay, so you just put on the 4 corners. This one you have. What? Oh, you have to choose k of those points. So you have all those points, and you have to choose a subset of them. But they're all within they're all on a square. K could be at most 25. There could be a 1500. What's that? Oh, 1500. No, 15. No, yeah, 100. No, 15,000. Why do 15,000? 15,000 choose. Is it binary search? circle in this. It's kind of, it's Manhattan distance, so you can think of it as a circle, really. Is it binary search? Why 25? 25 is so that you can do DP maybe on the binary search. If it's binary search, it would be greedy until the last number, right? I don't get to 25, honestly. Because is that the first point? I mean, I guess you could skip. Do you want to skip that many though? Are they all ints? They are ints. I don't get it. I don't get why this one is hard right. It could be more than that actually. Well, no, it has to be at most side. So I guess that part is good. I got it wrong last time, but if this is good, then let's try something bigger. Otherwise, let's try something smaller. I don't get the constraints. I guess we have to sort this in a smart way. Distance from... We have to sort this... Yeah, that's not that bad. Okay, so... Was it? Is it y? Y is equal to 0. That's annoying. Okay. And then if x is equal to side, then it is on the right. But we don't want it to be if y is not equal to 0 and y is not equal to side, so it's not top and bottom. Else if y is equal to side, top that depends xy, else p left as long as y is not equal to 0. Right, okay. And then now we just have to sort. Top sorting is, or bottom sorting is straightforward. The right, we want to sort by, all the x's are the same, so we, okay, so sort is p top, we want to sort by reverse is true, and p left reverse is true, and then it is just points is equal to right, okay. So then now we have a good function, we have a target. Is it that straightforward? I don't know. Do we always choose the first point? The answer is no. So that could be the point of contention, right? How do we choose the first point? Is there a pigeonhole thing? So target. So that means at most. I'm just doing calculator. 1500 times. Okay, so given a target, pigeonhole means the first target points, but you only do 25 points, so there is a smarter math here, because there are at most 25 points. That means that you should only cut off the start with the first 25. Okay, maybe. I don't know that that's quite what makes sense. I think that is reasonable, maybe. Okay, so then now for start in range of from, well, okay, that's fine, right? We want to say, okay, so current is equal to start, right? And then we want to go around. So for index in range from the start plus 1 to n, and no, I actually did define n. Then now we want to say if current, all right, so Manhattan distance, so yeah, okay, so if points of index of 0 minus points of current 0, so this plus this, if this is greater than or equal to target, then this is good. Then we have a count is equal to 0. Then now we have count is equal to 1. We have 1 point. Count increment, and current is equal to index. The only thing that we have to worry about is we have to check that this isn't too close to the start, right? Yeah, okay. So if this is true, then and if yeah, I'm worried about the calculations, but it's okay. If this is true, I guess this is just an AND statement, really. If count is greater than or equal to k, then we return true. So that's the early termination. Otherwise, we return false. And I think we may be okay. I don't know. How do I get index out of bounds here? Current is equal to start. Oh, so k has to. No, k has to be less than number of points, so that doesn't make sense necessarily. Why is this out of bounds? Alright, well, is it the start? Nope. Oh, not just that anyway. Index, what am I doing wrong? What am I doing wrong? Did I mess something up? This is very weird actually, so that is wrong. That means that I didn't count one of these. Let me double check. Yeah, these should be the same. So okay, so that's an easy fix or easy to debug. If true, so bottom, top. Yep. Okay, let's just print them out. Print points and this thing. Okay. Why am I missing 2, 2? 2, 2. This side is 2. It should be top. So Y is side, right? So this is top. What is top again? Top is if Y is 2. Why is 2, 2 not in there? Sad. Oh, because this gets checked first. Okay. That is actually... I didn't think the order of operation would come out there, but okay, fine. Okay. 211, is that the actual answer? I don't know. But alright, we have 26 minutes. Is it worth taking a 5-minute penalty? I don't know. Yeah, okay, I'm a little bit lazy. That's just YOLO. It may time out. Okay, wrong answer is even worse. Expected 8, we get 1. That is interesting. So, okay. Yeah, I guess that's fine. I don't know that I would have gotten it, but okay, so these are the points. We want to pick 4, so it has to pick all 4. So why is it 1? Target. So we're just not finding anything here. Why? K is 4, so we start off at 0, right? I guess I have to put target. Okay, 22, so 0, we found 2. Well, 22 is probably too big, right? We want 8. So 6, for 0, we still found 2. Why? So here we go. So what is 41.0? It's on the bottom, right? Yeah, 41.0, 42.7. Am I wrong with the Manhattan distance? I don't think so. Okay. Why? Oh, because... Wait. Any 2 points, but... No, I mean, that doesn't make sense. You never... Yeah, I don't think so. Okay, so why is 6 wrong? 6 is 2. Why is it 2? Start count. Index. Let's just figure it out. Okay. 6, 0. We find index 3. Why though? This is, I hope this is a silly mistake and not like something fatal, but I don't know honestly right now. Guys, and 602. Okay, so 25. See, oh, see, oh, wait, what? Oh, I'm just dumb. Okay, so that is actually really bad. This is no. Its index is current, right? So why would it be 0? This is a little bit awkward actually. That I kind of did. I mean, absolute value doesn't matter, but actually that's pretty bad still, for consistency's sake. I guess. Oh, that's because this is index and not. No. So something wrong is here. It is index minus start. That's why. Okay. Well. That's pretty bad on the. That's why you want symmetry. So that it spots you out, because something just weird on that one, right? 2118. Okay, so hopefully that's just a mistake. But I mean, it still may time out. I'm not sure on the timeout factor because I'm too lazy to do the math. But we'll see. Ooh, well, I'm not sure on the getting it right factor either. Huh. Okay. 46. So that means that we could be more aggressive and we're wrong. Maybe we had to choose more than the first 4. I thought we could skip by pigeonhole for 4, but maybe k plus 1? I don't know. Would that fix it? 53. Yeah, maybe we have to skip the first 4 for pigeonhole reasons. I don't know that that's good enough though, honestly, but also k could be n, but this would never run. So okay, I mean, I'm willing to YOLO this just because I have no idea, right? Wouldn't be surprised if it's wrong. Yeah. So then now, I wish that this came up a little bit earlier because I'm guessing that this k has to be like a little bit or a lot bigger, right? But I don't know what the number is. So yeah, so if we increase this, we get the right answer. But then, you know, then here you actually want n, but then you have n squared, which is also obviously not what you want. I thought it could be k by some pigeonhole, but yeah, I don't know. Maybe there's something about target, but that's still Yeah, I mean, binary search means that it's going to be just timeout, right? I mean, this is fine, but that's, yeah, I don't know. I mean, this is right, but that's because n is small. Maybe n is small enough. I don't know. All right, I think this is wrong, or I think this is too slow. But I'm going to YOLO because I don't really have it. I mean, I guess I have to figure out what the right number is really. We have to skip some numbers. It just means that we have to. Yeah, I mean, I thought this would be n squared, but I was hoping that maybe n squared would be fast enough, but clearly it's not. So how would I reduce this? Choosing the first point is critical. Is either that or we have to do some DP thing. But it's not clear to me that DP is cleaner. Because you have to choose to start. The looping thing is the tricky thing here, right? So I don't know. And you could always choose, like, even if I choose 1,000, it's going to be a number that's bigger than, you know, it's still, well, 1,000 might still time out. I was hoping that there's some pigeonhole with k, but maybe I have to figure out a little bit better math with choosing the first point. I don't get it though. Why would it be better? Because you loop. Is there something with the loop? Is there like a sliding window thing with the loop? The thing is that this is greedy. but why doesn't greedy work? Because it's index k, maybe. Can we do that? Now we have to figure out what the previous one is, and having the previous one is no Gucci. Well, you could do a binary search for the next number. But yeah, now, yeah, you can. And because you only have to do binary search 25 times, then it's not O of n. Okay. 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 Fine. Okay. Let's see. So then let's convert this. Okay. Yeah. Well, okay, so let's just say the first point is, so then you have side, so then the side times 4. So okay, so we can just measure it from the distance from 0 on the thing, right? So then now, okay, so then, okay, for x, y in points, okay, you could get this, Larry. Focus, because then it's n times log n. Okay, maybe that's still too slow, but I think that makes sense. At least fast enough for me to go to Java if I have to. Okay, so here we want to convert it into the last point. Okay, last x, last y is equal to 0, 0, say. The distance, right? So absolute plus okay, right. Oh no, it's delta plus it's a prefix sum. So let's just start at 0. Okay, and then we just remove the first number, whatever. Okay, right. So then now, what would this look like? Let's reach for parity first. So okay, so then now, also this is wrong. I don't know what happened here, because I think there wasn't one of these like a 2 or something. That's pretty bad, actually. I don't even know what the answer is, but wait, let's check, because I don't think okay, this is no, this is 53, and we have to choose k is like k 1,000 or something, just to kind of get the right answer. Let me screenshot this for okay. Okay, so then now that means that if points of index minus points 2 of index minus points 2 of current is greater than you go target, and points 2 of so you have to loop it around, which is index minus points 2 of start. It's something like this, but we have to wrap it around, right? And you wrap it around when start is plus side times 4. right? It's side or side. Yeah. Okay, that's not right. That's really sad actually. I was hoping this was right, but why? Okay, let's print. See what that's 2. This is not 2. Okay, fine. Oh, because I didn't do prefix sum. I said I would, but then I lied. Okay, hopefully this is fine. Okay, still not fine, but 6, 8, okay. 2, 3, 4, 5 is right. Why is it wrong? Okay, oops. Let's take away the beginning loop first. Okay, I mean this is wrong because we don't have to start. So start is wrong. So the start should be okay, so there's this. So each side is 2. So this is an 8, right? No, it's the, okay. This is right. It's just that now you have to, yeah, okay. Because that would never be true. Okay. Is this right-ish? No, it's still wrong, but what is this? The last 2. Why? Uh, 18 minutes. Should be able to get this. Oh well, maybe anyway. Why? The annoying thing is that the one I know the answer to, it doesn't, or like that I can work out easily, because there should be like 53 or something, but which one is this? Is this one? And it should be 53 or something, right? So why? So 8. All right, let's see. Let's print. So this is wrong too optimistically. So we can do something like this maybe. 53 is good. 62 also thinks it's good. With the start of 0. Okay, so that's easy to look at anyway. So 1, 2, 3, 4. Side is maybe, but this thing is wrong maybe. Is it side times 4? Okay, so 13, which is not bigger than target. Oh, it's not current. It is index. Oh man, how did I make the same mistake twice on different things? Okay. Alright, so this is right, but this is still going to be too slow. So what do we want to do? What we want to do is now we want to binary search. So that means that, okay, for start in range of n, current is equal to start, count is equal to 1, and then we just binary search, right? So maybe k minus 1. Or maybe just while count is less than k, right? We go, okay, so then we want to binary search points to, oops, how did that get over by of the current plus target. So new index is equal to here, and then yeah, then current is just equal to index count increment by 1. If index is greater than equal to length for points 2, then we break and no Gucci. So if count is equal to k, then oops, then we return true. Otherwise we just keep going and we return false eventually. Okay. Alright, so this last time, oh, the code was so fast last time. Code is also fast this time, but it's wrong, which is not as good, not as brand. Oh, we have to keep track of the last one, right? So okay, so okay, we have to write this part. Okay, so if then this is good, so that means that if this is less than target, then we also break and don't increment, right? Is that not it? Start right? Well, at least this is wrong for this one, so that's good. Index. It's not current. Current is wrong. It's points to of current. That's why it's so easy to find matches. Yeah. Okay. Nice. I think this is right. Where's my screenshot? I'm not showing the last number anymore. But 23324. Okay, so let's go. Oof. I have 5, expected 3. We have 12 minutes. Hopefully I get to finish this. Okay, so I mean this is easy to debug. The key note is that we lost the number. So that no we didn't. Okay, so 2 8 you go 3 12, so 20 21 33. What is the side? 9 is 36, so it's 38, right? So okay, so it thinks the answer is 5. We want 4 sides, so 36, so 38. Is that not right? Am I misunderstood? Maybe I'm, well, that would be really bad if I misunderstood it the entire time. Then I'm just sad. But did I do the math wrong? Okay. Oh no, the points are here. So 2 8, and so 2 8, and then 5 5 4 is weird, right? Yeah, this is sorted incorrectly. On the right side, so that's not the right side, that's the left side. Did I do something wrong? Top left. Left is 0 1, so this is the top. Okay, so top we want. No, that's the right side. Okay, which is actually, oh, because now we have to, okay, we have to connect it because we wrapped around, so the Manhattan distance is no longer true. Okay, so that is at most okay. What does that mean for me? Because each side is 9, so this should be at most 9. No, but you can't do it quite that way because then it wraps around a weird way. But the way that I calculate this math as well. Okay, that's fixable. Because this is maybe too close to something, I don't know. But something is off here. Also 0, 1 to 1, 0 is only 3 away, so yeah, the math is just wrong because everything is cascaded. Okay, so then here, okay. Okay. Let's just do it this way. P bottom, P right. No, let's okay. So then let's just do it. Delta is equal to, from the bottom, it's going to be x plus y. Okay, that's fine. And that's not even the delta. Let's just do it this way. Okay, we don't need this. We don't need this. We have 8 minutes. Hopefully we're good. This is going to be a side plus plus the x element. So it's going to be x plus y anyway, right? Okay, and then now top, it is going to be side times 2 plus distance from the corner, so that's going to be n minus, or side minus x. And then left, it's going to be side, and then it is going to be side minus y. Okay. 3. Okay. I was just trying to be too clever, or just trying to be lazy on that one. I think, okay. Whew. But not good enough because I don't know how to do Q3 apparently. And 1,000 people got it. How does 1,000 people know the answer to this one? Am I just being dumb today? Maybe I am. Maybe I just gotta do this. I don't know if this is quite right, but maybe we just gotta YOLO inverse math. Pow. Last one. Power to -1 mod 10, right? Does that even work? Would this give me an error? Yeah, that's what I thought. Can I do like a mod 5, mod 2? Still not immutable, huh? Decided that, did I do the... I don't think this is right. I don't think I just got the parameters well. So that would be funny. Okay, well, I guess I don't need F. Just wanted to be... Well, all zeros is probably not right, so okay. Which one though? Oh, because is it 0 or something? Then I don't know how to do Q3, huh? For 25 minutes. I mean, it's fine. I mean, I'm gonna eat some waiting, but I mean, I feel like I am not knowing something, so that's okay, I suppose, in the sense that that means I'm gonna learn something. Maybe I could have done Q4 earlier if I had looked at it earlier, but not a huge deal. Yeah, I don't know. I mean, it's gonna be 0 eventually, so I don't even I don't know how to do it necessarily. Memory limit. Oh, not even. Huh? That's actually surprising, but I mean, yeah, I don't know. I was hoping to do some funky math with this one, but I mean, I'm not gonna get in 3 minutes if I didn't, you know. I don't get it. Maybe I need to reset, and I'm just not resetting correctly. I think what I was doing is right? Contribution. Am I though? All right, let's see. Maybe I am doing it wrong, and I didn't realize it. Okay, so 390. You add them. This is 2. This is 9. Right, and then now. Right, and then this is 2, say, and now this is 1, right? So then now you have this thing, which is just Pascal's triangle. I don't know how other way to look at Pascal's triangle. You do, right? The 9 contributes to here and also here. So there's a 9 here and 9 here. This is the classic 1, 2, 1. And that's after 1 iteration, right? So that means that, yeah, this is 1, 2, 1. This is 1, 1, 1, right? So this 1, 2, 1 minus also 1, 2, 1. I don't know. I don't. I mean, I can't think of it without Pascal's triangle, and I can't do n square Pascal's triangle, so I'm just really weird. I mean, yeah, I mean, it is Pascal's triangle, but I guess I'm just missing something obvious. Maybe I'm just really bad at math. That'll be funny if people just did it n square. Okay, it ended. Do I get a hint? Let's see. Let's look at UI. I mean, I was thinking of along those lines, but I just don't know how to do. I mean, I knew the Pascal's triangle immediately, but I don't. What does this do? Okay, so for given n, yeah, I mean, we got this part. I don't know. People are saying a lot of things, but it don't actually say. I don't know what this is. This is some crazy talk. I mean, this looks like, honestly, an obfuscator, just trying to hide the fact that they're cheating or something. But I mean, I don't know. Maybe I just don't know enough math. It seems like a lot of people are just like cheating. Also, just like random code that doesn't make sense. But I guess this is just. I guess there's just a lot of hard-coded math on keeping track on 2s and 5s, which I guess I was and multiple inverse. I don't know. So we count they count the number of 2s and 5s on the thing, and then they divide it as well. Is that good enough? I guess I was thinking about that, but I mean, I didn't have this part in my head, but sorry, I'm just like kind of chatting with people on the Discords. I mean, and also like a lot of this code is probably like cheating code, so like it's, I don't know. I mean, I guess the idea I already had, but this is just such a silly problem. Like, I don't know. Now this is kind of cute, actually. Maybe that's a good idea. I don't know if I could figure this out, but all right, I mean, I get the idea. But I didn't really look at the code tightly, so maybe I can kind of figure this out. Okay, so that means that. Oh well. Yeah, I mean, I don't know. I guess this was this one. I guess I'll just leave it up. But okay. So this idea I did was thinking of it, but I didn't really think about how to look it up. But maybe it wasn't that bad because there are only 10 possible entries for 2 times 5 possible for the last digits. Okay, so let's see, right? So okay, so yeah, I was actually thinking about this, but yeah. So what does this look like? Was it C choose K? What was this? But I just didn't think that. I thought maybe I was missing something more fundamental, honestly. Like I didn't want to grind it out, and also I spent all my time on Q4, which honestly I thought would be a little bit better. So okay, so you have this, which actually I thought it would be more predictable. I mean, this is actually Sierpinski's triangle, right? Something like that. So I mean, I spelled it really wrong though. Sierpinski's triangle. So okay, so this is just Sierpinski's triangle on mod 2, right? So I guess is that what this is doing? Oh yeah. Oh, there's actually something. And yeah, and honestly, as soon as if I had seen this, then this would actually be pretty obvious what mod 2 is. So then maybe we could have something like so we've got let's just do mod 2 n and k, then what is it? I actually don't remember the formula for it. Is it a factor? Maybe I'll Google it. On whether a cell is 0 or 1. I feel like there is like a. I'm looking at the Wikipedia article. There are multiple ways to generate this, but yeah, I don't know. But I don't know the formula actually. And Wikipedia is very slow on it. I mean, I could figure it out. Because this is 1, 2, 4, 8, 16, right? So then it's just subdivide. You probably could even do better than that by just generating this. Frankly, I think it's something on the bit. Right. So 1, 2. This is every other one. 2, 1, 1, 2, 3, 1, 2, 3, 4. Actually, I don't know though. I guess he does, but actually, I don't know this one. Why do I know this one? And that's an interesting way of doing it there. Maybe I don't know how to. Okay, let's put this on for now. Let's look at 5. Right? Is 5 any different? I mean, it's obviously it should be different, but is there anything we can exploit? There is some like Sierpinski-y thing to it because of the zeros, and then you have 3. So, I don't know how to. They just. I guess they just kind of really hard coded it, huh? Because basically it's just the states, right? So then it goes from well, they even cached it actually, but I don't know how. Okay, maybe I don't know how to do it this way. Maybe I was lying. Apparently I could have used the Lucas theorem, but I thought that would be too slow, honestly. But yeah, and this is maybe more similar, but and mod 5 is crazy. I don't know what the intended solution is, because I feel like these things are crazy people's solution, right? Like you're not really solving problems at this point. You just random knowledge. Maybe this is well, okay, this is just Lucas, which is also random knowledge. This isn't. It's just not a good problem. I mean, Q4 was fine, and then it just became a problem of who skips Q4 the fastest, or who skips Q3 the fastest to do Q4. But and this is a very bad problem, honestly, because there's no point. I don't know. I was hoping that we'd learn a little bit more, but I don't know that. I mean, I don't know that learning. It's just. I'm kind of annoyed at this problem. That's why I'm like trying to figure out what I want to do, because this is just silly. I mean, I'm not just to be clear, I'm not like making fun of these people's code. I'm saying that the fact that you need this is silly, right? Though I would also say writing all this code in 18 minutes is, I don't know if I believe that. I don't know. I don't know who this person is, so maybe they did. But maybe is it studied? I don't know. Maybe it's people. Maybe just some people know it. Maybe it's Googleable. But yeah, I guess I'll just do Lucas. I kind of was not doing. I didn't think it'll be fast enough. But yeah, during the contest. But and I thought that there would be I thought there'll be a more first principle solution, but I guess it's fine. Okay, fine. How do I write it? Right. So right. So you want and you need CRT. Okay. So how do I want to write it? Right. We want to calculate NK. Okay, so fine. So we want to calculate whatever calc and choose I with a mod of let's just say P2 is equal to this, P5 is equal to this, and then I don't know, do some magical things later. We're not going to be close yet. And then the idea of Lucas is going to be just n in base p, right? Yeah, n in base p. Okay, yeah. Okay, fine. Is it? Yeah, okay, fine. I think that's right. Right. So then for or while n is greater than 0 and k is greater than 0, because otherwise if one of them is 0, it doesn't matter. Then it's n mod p, right? So the top, maybe bottom, is equal to k pod p, and then it is just yeah, t. Oh, I see. The way that they did it is with Lucas then, right? I thought that they did something more clever, but I guess so. I actually did know Lucas, but okay. It is what it is. I thought that there'll be, so then T choose P, right? So here that's why they had some stuff like that. I thought they did something a little bit smarter, but yeah. Yeah, okay, so n in range from 5, k in range of n, right? Then first p5 dot append to do, and then p5 dot append, the last array dot append, whatever, just be lazy, right? So math dot comp of n of k mod 5, right? Okay, so that's how they get the thing, right? I mean, I know that that's wrong. I just want to see the P5 part. Okay. So, yeah. I mean, I'm clearly missing one thing, but that's fine. It's this thing. Okay, right? And then now you could do the same for 2. And that's easier than, I guess that this is easier than constructing the whatchamacallit, Stravinsky's triangle. So then now you have all, we multiply by, oh, I guess this is actually important. If p is equal to 5, then this is equal to p5 of tb, all times this mod p p, right? Mod 5, I suppose, and then else is going to be a 2, so that's fine, right? Yeah, okay. So then now we need Chinese remainder theorem to get the rest. But even then, it is not that bad, right? I mean, okay. So here we can actually move this out, and also I destroyed this end by accident, so that is actually not great. Not that bad. And then CRT, I actually don't remember how to do CRT off my head. Let's see. I don't really have code written. I mean, I guess I could find it. Let me see if I could find it. Is there anything? Is there a Python library for CRT? Chinese remainder theorem? I guess I should have just done it. Doesn't seem like it. Other than some code I find in Python. Okay, fine. How do I do it? Let me see. I don't remember. Okay, so yeah. Maybe we will just code a lookup. Yes, you go to 5 times 2, is it? Right, and then for I in range of 2, for j in range of 5, then lookup of ij is equal to, I don't know, calc ij, right? Or crt ij, I guess. Can I just steal someone's code? It's not that interesting. This part is not that interesting, I think. I'm gonna steal someone's code. Let's see. Oh, they actually, I guess you can brute force this. Because there are only 10 things, but that's a little bit awkward. Yeah, I guess you can brute force this. That's actually pretty nice. Okay, fine. I did not need to know that. What I want is actually, yeah, for I in range of 10, then yeah, lookup of I mod 2, I mod 5 is equal to I. So then now, yeah, okay. So then left side, we just go right? And we can now do math a little bit dumber. And then look up of P. Oh man, this is terrible naming. Okay. X2, X5. Left multiplied by this. Also mod 10. I mean, you can make that a little bit more efficient, but that's fine. I think I just spend most of the time trying to figure out. Yeah, I mean it's this times what's it called? The input, right? S sub I plus 1, right? Yeah. Okay. I don't know if this is quite right. I mean, I think the idea is right. I just oh, it's not CRT anymore. It is. Oh, actually, you don't really need it anymore because we already did it. P2 is our bounds. Why? Tell me why. P2 TB. Why? Huh? Did I do this one wrong? 0 1 0 2. Right? Okay. Let's see. Should be. Yeah, I can't imagine it be that wrong. 0 1 1. Oh. I guess the other cases are 0. Yeah. I forget that. Yeah. Okay. If t is greater than b, then r is equal to 0. Else you have this thing. What are you feeding me? 0, 1. Am I printing anything else? Where's this one? Oh, 1, 1 is good. 0, 1, right? Oh, yeah. Did I do it in the wrong order? I did it in the wrong order, I guess. Well, technically, I did this one in the wrong order. 1 choose 0, 1 choose, or 0 choose 0, 0 choose, or 1 choose 0, 1 choose 1, right? Why do I have 0, 1? Or where do? Oh no, this is normal. Whoops, I just had this. That's the part that I messed up. Okay, so that is nice, except for it's wrong, but it's nice until the wrong part. Why is that? Oh, because I always return true, so that is clearly not right. Okay, still not right, but that's okay. I'm gonna take a look at least these 2 examples. Zeros are definitely not what we expect. So yeah, let's see. Either that lookup is wrong too. Okay, well. No, lookup looks rightish. Yeah, I mean, looks. I mean, maybe it's reversed, but I think it should be okay. Okay, so definitely something funky. It's because I started at 0. Okay, Larry. True, false, 2 and 6. Is that even right? We can't figure this out, right? So no, it's 4 and 8 and 1 and 1. So that's just way wrong, probably. And I just got lucky, maybe. So I have 1, 3, 3. That's okay. So you can see that here, at least that's good in that. Yeah, it shouldn't be 1, 3, 3 for that. So this is actually n minus 2. And we were very lucky, I suppose. Okay, 0, 0 is still wrong. 8, 4 is good though, right? Yeah, 4, 8. But 11, 11 is not quite what I expected. 1, 2, 1, 1, 2, 1. Right, so the left side is... let's see. What is the first digit? 1, 2, 1. 1, 2, 1 is right. So then the right side is going to be 1, 2, 1. On the on the left side should be 1, 1 of 3, 2 of 9, or 9 of 2, I suppose. So that's 18, 21. That's not right. Did I do something wrong on this one? Something's weird in this one. So then reverse is 2. That sounds right, actually. Would it look up? I mean, this is the expected answers are right, but something is really wrong here. That's why I'm like a little bit wonky. Why is this 9? Oh, this is 4. Okay. Oh no. 3 times or 3 plus 18 should be 1. So this should be a 1. I don't know why that is. of 4. Lookup is 2. I guess the only thing that I didn't add is in case I have an off by 1. No, it's 18. Oh, I am dumb. Why did I have this? I think I just confused things. Okay, 1148. We're Gucci. Maybe I should have done it with Lucas. I did actually know it, but I didn't really think about how to implement it, honestly. So maybe I just kind of thought that was a little bit weird. And this may time out, I guess. Apparently. Oh, okay. Yeah, but yeah, I mean, I also thought it would be too slow, and 8 seconds honestly doesn't really disprove that. So I don't like. It's true, but also like I don't know. Well, it's a very sad. I mean, I don't know. Okay, I mean, sorry, I'm just like kind of think about like how could I have done things differently, and I guess, yeah, I mean, I don't. If you knew that, and I'm not picking on this person. I don't know who's cheating or who's not anymore. But if you knew this, then maybe you could have done this quicker. I don't know. I mean, you probably didn't need to construct this. You could have just written for loops, but. But actually, I mean, even with all this, I mean, this doesn't take that much pre-processing, I guess. Maybe I could have optimized the other parts. The other parts maybe being this part, I suppose. Maybe this if statement, this, oh, and maybe this I could return because if maybe that could make sense actually. Let me see how much faster, slower, whatever it is for this one. And you could maybe even do some maths on the fact that you know, on adjacent ones it's a little bit like you could do math that way. So actually this actually saves it like half the time, right? So that's actually crazy. But yeah. Yeah, sorry, I'm just talking on the Discord. But it is a very sad one. I just said, like, literally, I just. Yeah, I don't know. Anyway, friends, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, an okay contest. Stay good, stay healthy to mental health. Let me know what you think about this problem, this contest, everything in between. I'll see y'all later and take care. Bye bye.